The fourth one. So did you solve this? Which one? Oh, so this was the last one, right? Okay. So did you solve this question on your own?
Yes, sir.
Good. Any doubts in this one?
I don't think so.
Good. Very good. Very good. So now let us move further, right? So we are calculating. We have calculated electric field due to single charge, that is simply kq by r square. Electric field due to multiple charge, that is simply the superposition principle. And there's one more question which is remaining, the sixth one, right? So let's do this one and then we'll talk about the diagram, right?
Okay, sir.
Okay, so yeah, let me. And today's class would be of 1 hour because I would be traveling right today. So sorry, and yeah, I will make up for this time, right? So at
Oh,
some later. And are you attending Amna Ma'am's class for the third chapter? Are you doing that?
not yet. They did not inform me.
Oh, please ask them, right? Because it's already 27 and you have an exam on 18th, right?
Yeah.
So it,
I
yeah, yes.
yes, I will. Actually, I was also traveling. That's why.
Please ask because you will have your exam on 18th of September, I guess, right? And this will take some time to complete. So yeah, the third one, right? You would be having your third chapter. So drift velocity, Ohm's law, microscopic form of Ohm's law, and all those things, electric current, and all those things would be there, right?
So,
So yeah, resistance and then cells and the internal resistance of cells, and then potentiometer is not there, but Wheatstone bridge would be there, right? So up to this point, you
mm,
have to, and Kirchhoff law. So you have those two questions in your NCERT book. Practice that one, right? So yeah, these are the things that you have to do. So let us start with our own thing, right?
okay, sir.
Okay, so consider a system of n charges, and they have this thing we have already talked about. So let's discuss this thing again. So we have Q1, Q2, Q3, up to Qn. Right. With position vectors, let's say we are calculating the point from here. So let's say this position vector is R. Right.
Mm,
And from here to here. This one is R2. This one is R3 and so on, right? The last one is R3, right? So, yeah, relative to some origin. So let's say it is related to some origin. Reduce the expression for the net electric field P at any point P, which with position vector RP due to this system of charges, right? So this thing we have to calculate. Oh, so okay. Okay, so then this thing would be, now this is not the actual diagram, right? Then the diagram is different. So let's say this is some origin, right? This is some origin. This is R. So this is, right? We have done it differently, but they are asking a different question. So this is the correct, right? This is R3 and up to R, right?
mm,
Now they want us to calculate the electric field at some point P. So this is some point P, right? And this one has a position vector 4. So this one has a position vector y. This as RP, right? Right?
yes, sir.
So now, if I want to calculate the distance or displacement between Q1 and P, what would be the displacement vector? Can you tell me that? What is the thing that we have to apply?
Will it be like a unit vector R1, R cap?
R cap. Okay, so forget about all these diagrams. Yeah. So let's say this is some X and Y. This point, let's think about one charge only, right? So let's say this is some charge Q. This is some R, right? And this point, let's say you are calculating the electric field at this point R, right? This is some point. So if I want to calculate the electric field, I need this distance, right?
Hmm.
So what is the thing that you are seeing now? What is the thing?
We have to take like from B to P the
Yeah.
distance.
So BP vector we have to find out, right?
Yeah.
So if I write the electric field at P, let's simply say the magnitude. So this would be K Q divided by BP square, right?
Hmm.
And if I put the vector, so this would be KQ by BP square and then BP hat, right?
Hmm.
Because
Yes.
we are going in this direction, right? If it
Hmm.
would have been this direction, so that would be PB hat, right? But we are
Hmm.
going in this direction. Now how can we calculate this BP or BP hat? We know the triangle's law, right?
Hmm. Yes.
So from triangle's law, what would be the form of triangle's law? This is vector, this is the vector, and this is the vector. So what would be the triangle's law if you take from this point? What would be the triangle's law? Let's say this is some R, let's say this is 1. So R1. What would be this? How can we relate all these three? What would be the triangle's law?
Are we gonna take the side AP and AB?
Yeah, okay. So you can tell me about in that form also. Right. Yes.
So will it be AB under root AB square plus AP square?
Triangle's law, triangle's law. Only the triangle's law. Let me just
Hmm.
tell you this thing. This is A, right? This
Hmm.
is B, right? And if I go in this direction, then this would be A plus B. That is what the triangle law states, right?
Yeah.
So if you go from here, then if you connect this point, so that would be the resultant, right? This is the triangle's law.
Yes.
So if I see that scenario in here, so I'm going from here and going from here, and then I'm connecting this. So then what would be
Hmm.
the triangle law? Triangle law would be AP vector.
AB
This would
plus
be AB plus BP. Am I correct?
yeah.
So this would be AP is RP vector, right?
Hmm.
This would be R1 plus R1P. But what I want to calculate? I want to calculate this R1P. That is the displacement, right? So this
Yeah.
would be RP minus R, right?
Okay.
Is it clear?
Yes, sir.
So then I can, then BP is this thing, right? So
Hmm.
then I can write this as KQ divided by R1P magnitude only, and then R1P hat. Is it
Hmm.
clear?
Yes, sir.
Because R1P direction is this one. If I talk
Hmm.
about RP1, so that would be in opposite direction, right?
Hmm.
Okay, so this is the thing that we have to remember. This is due to one charge, right?
Hmm.
Let's name it Q1, right? So this would be Q1, and yeah, Q. Clear up to this point?
Yes, sir.
So let's do the same thing in this scenario, right? So
Hmm.
one position vector would be this one, or one displacement would be this one, right?
Hmm.
And from this one, this would be R1P vector. This one would be
R2P vector.
R2P. Good. And this would be RNP vector. Right. So
Hmm.
if I write E1, we have just understood this would be K Q1 and R1P square and then R1P hat.
Cap.
Right.
Hmm.
Similarly, E2 would be KQ2 divided by R1P, right? So 2 square and R2P hat. And finally, En. So this would be KQN divided by RNP square and RNP. And then I can write E net, superposition principle, right?
Yeah.
So E1 plus E2 plus E3 plus so on plus E. And finally, this would be KQ1 by R1P square and R1P hat plus KQ2 R2P square R2P hat plus so on. And
Hmm.
KQN RNP square and then RNP hat. But there is a simple way in which we can write this thing, right? So let me just erase this part. Right. This part you
Hmm.
should write there so that you just get the idea, right? So I will leave
Hmm.
this part. And yeah, finally, there is a simple way. So this is 1, 2, and 3, and so on. So I can write it in terms of
Summation.
some absolutely correct. So I can write summation. K is a constant, right? So I can take it out. And this would be Qi, right?
Hmm.
And then this would be RIP square. And then this would be RIP vector, right? Is it, oh, RI, this is I, right? This is looking like 2.
Hmm.
This is it correct? What do you think?
We have to write the N
Oh,
and I is equal
okay.
to.
So I equal to 1 and then good. Yes.
Hmm.
Yeah. So this one. Now is it correct?
I guess yes.
Okay. And then we just put the value of Q's. That is 1 by 4 pi epsilon naught and summation I equal to 1 to n Qi and then RIP square and RIP will be the answer, right? What they are taking. So 1 by 4 of epsilon naught Qi RIP square. Yeah, this one. So this is correct, right?
Yes, sir.
Okay, so please note down the question and then the solution, right?
Okay. So can you see the answer?
Yes, yes, yes. So yeah, write down this part first, right? So it would
Yes,
be,
sir.
yeah, write down this part and then
So can you scroll up now, please?
yes, yes, yes. This part you have noted, right?
Yeah.
So now let us, yeah, move on.
Done, sir.
Good. Okay, so now, yeah, now we have the next set of questions, and those are related. Those are related with the diagonal, right? So in our syllabus, we have to do only the equatorial point and the axial point, right? Yeah. So we have discussed it already, but let's discuss that thing again, and we have to remember only a few things in the dipole case, right? So whenever we have two charges which are in opposite polarity but equal in magnitude, and they have a very small separation, right? Then that is called a dipole, right? So that is a dipole. And for a dipole, there is a dipole moment, which is 2aq magnitude and goes from negative to positive, right? So let's quickly have minus q and q. They are in equal magnitude, but they have a small separation. And generally, we take it as 2a to help in the calculation. So this is, and then we have the dipole, which is p. This is p into p hat. And p hat is this direction, right? And magnitude of P is 280. So this is dipole. Now we have the electric field of dipole. So electric field of dipole has 2 points. Right, so this one is, let's say this point is the axial point. And this point, so this is A, this is A. This point is the equatorial. Right. So equatorial point has the electric field in this direction, opposite to dipole. This is dipole. Electric field is in the opposite direction, and this is minus Kp by R. Right. And this one is in the same direction, and this is 2 Kp by R. Right. So electric field for a dipole varies as 1 over R. Right. This is the important thing that we have to remember, right?
Okay.
Okay, so let me ask you a very simple question, right? Yeah, let me ask you a very simple question. And yeah, so this you can do very easily, right? So calculate this first question. This is related with dipole, right? Please calculate this first part. And tell
Okay.
me what is the answer you will get.
Sir, it is 5 into 10 raised to minus 9 centimeter.
5 into, yeah, so this is,
I said centimeter.
yeah, so no, it's, yeah,
Kilometer.
Coulomb meter, yeah, Coulomb meter. So this looks like centimeter, yeah, Coulomb. Okay, that is correct. Good. Now let us do this. So which time? Oh, we have good amount of time, right? So then we can do, or you can do this question as well, right? So yeah, then try this question also so that you
Okay.
have your practice, right? And then, yeah, so yeah, you have to just figure out what point we are calculating, whether it is axial or whether it is equatorial, right?
So it is both, right? Equatorial point and axial point. At P, it's axial, uh, and then at Q, it's equatorial. So we have to calculate both the things, right?
Absolutely correct. Yes. So part A is axial point and part B. Remember, in this question, they have not given, they have given 2A, right?
Yes.
So yeah, you don't have to use 2AQ. You can use simply charge into separation. So that thing is there. And yeah, you are correct. A part is axial point. B part is equatorial. Yes.
Okay. So in axial it is 2.66 into 10 raised to 5. So I guess it's B.
Yes, B is the correct one, right? Good.
Okay.
And yeah, you also got 1.33, right?
I didn't do that.
So,
I was
so
just calculating the second thing and then I felt
yeah,
hefty.
yeah,
So I
yeah.
was like,
Yeah, so there are two options, you see. Oh,
yeah,
but both the options are same. Oh, no, the magnitude is different, right? Yeah, so 2.66 and 10 to the power 5. Right,
yeah.
that good. So it's correct, right? And AB, which means that if this is A, this is B, this should be minus, this should be plus, right? The separation is 5 millimeter,
Mm,
and we are calculating, let's say from this distance is 15 centimeters, right? So
yeah,
why we can apply, right? Why we can apply? Because in the derivation, what we do? In derivation, we get this kind of scenario, right? And then we neglect this part, right?
yeah.
And why do we neglect this part? Because R is very greater than E, right?
Hmm.
So yeah, that is the same condition which is applying here. So A is 2.5 millimeter, right? And R is 15 centimeter. So your R is very, very greater than, right?
Hmm.
So then we can apply this 2 kp by R. Otherwise, we cannot apply this thing, right?
Okay.
Yeah, this is the condition for which this formula holds, right?
Hmm.
Okay, so good. Then we have all the got. So now let's, yeah, this question is an easy question, right? So although it is a neat question, but we can apply this question. Oh, both are, okay, one should be, right, one should be minus. So it's a problem in this. One should be minus, right? And yeah, so let's say that not this one, but this one, right? So this should be minus because whenever we are calculating dipole, so both should have opposite polarity, right?
Yes.
Okay. Now there are we can simply do this question, right? So we have this is x, y, and this is z, right?
Hmm.
Now they're saying that a system has two charges. QA is situated at 0, 0, minus 15 centimeter, right?
Hmm.
So where is that point?
In Z axis minus Z.
Z, man minus z, right? So it should be in yes, right? This is 0, comma 0, comma minus 15 centimeter, right? This is QA, right? And then where
Yeah.
is QB situated?
In the positive Z axis.
Positive z. So somewhere in here, same at same distance. Right, but
Yes.
this is 0, comma 0, comma 15 centimeter. This is Q. Right. So if I ask you about the direction of the dipole moment, what would be that? This
It
is,
would be
remember, minus, this is plus, right? So what should be
would
the direction?
towards the negative one.
Minus to plus. This is what direction?
It is,
It's positive z direction, right?
yeah.
So that would be K, right?
Yes, K cap.
So we had K. Now, if we talk about the magnitude of P, so that is simply the charge into separation, right? Let's say D. So this would be Q is 2.5 into 10 to the power 7 Coulomb. So that is an assignment. So we are saved. And then D is how much? What is D?
15 centimeter.
Separation between those two charges. That is 15 here, 15 here. So 30, right?
Okay, so we can add those.
Yeah, yeah. So if we, let's say that this is from here to here, that is 15. And from here to
Hmm.
here, that is, this point is minus 15. So from here to here, you have 15 distance. From here to here, you have 15. So total distance would be 30, right?
Okay.
Or we can also think about the distance in this way. So x2 minus x1, or y2 minus y1, or z2 minus z. So z2
Okay.
is 15, and minus of z1 is minus of this thing. So 30, right? So whatever
Okay.
way is, yeah, whatever way is comfortable or we can easily understand. So that is, yeah, we can also think about the distance between these 2 points, right? So that is 15. Distance between
Hmm.
these 2 points is also 15. So we are
Hmm.
moving 30 units in distance. So yeah.
Hmm.
And if it would have been some other point, let's say all these points would be there. So then distance would be, let's say PQ would be root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. That is the distance formula, right? Between x1, y1, z1 and x2, y2, z. So P and Q. That is the distance formula that we use. But we don't have to use this complicated one because this is 0, 0, and this is, yeah, so we can just, okay, so this is 30, so this would be 2.5 and then 75, so this would be 75 into 10 to the power 7. Oh, this is centimeter. Okay, this is very bad, right? So
Hmm.
2.5 or 10 to the power 7, 30, and 10 to the power minus 2, right? So
Yeah.
then this is 75 into 10 to the power 5. This one is 75 and 10 to the power 7. So this would be 7.5 into 10 to the power how much? 6, right?
Yeah.
So where do we have? Oh, we don't have that answer, right? Hmm. Okay. Where did we, yeah, where did we miss the point? This should be 7.5 into 10 to the power 6, not, why there is a minus? Oh, there is this minus. Oh, oh, okay.
Um, it's -7.
Yeah, yeah, yeah. So this is, that is why we were thinking of why this is, yes, yes, sorry, sorry. So this is -7, this is -7. So this would become -9.
Mhm.
Then this would become -8. Right. So then this is correct. Right.
Yes.
Please note down this one and then we'll do the next question, the second part, which is also, yeah, can be related with NCERT. Okay. What is this? Yeah, whenever just note down the question as well as the answer, and whenever you have noted, please tell.
Yes. Done.
Done. Okay, so now let us do the next question. This is okay. So three charges. I will do only this question, right? Because then the other questions are not. Yeah. Fourth one is also an easy one, but yeah, you can try these, right? Because these can be asked in your exam. These are very important question on electric time. So yeah. So three charges plus Q and minus 2Q are placed at vertices of an equilateral ground. So let's say that this is an equilateral plane, right? And let's talk about the axis. So let's assume that this is y, this is x, right? And if this would be at the origin, this would be at 0, 0. And let's say that if the triangle has, let's say if the triangle has a distance, right, or side A. So this would be a comma 0, right?
Yes.
And this would be how much? What would be this point? Can you tell me?
It would be A00.
A 0, 0. No, we are only talking about two dimensions, x and y.
Okay.
So what would be the coordinate of vertices? How much is this distance and how much is this distance? Right. That is the question.
It's an equilateral triangle, so it will
Yes.
be equal distances, like the sides are equal. So
So yeah, so we have to find out the coordinate. Do we need the coordinate of that one? Okay. So we don't require actually. We don't require that, but yeah. So this part is the median. This will divide it in half. So this would be a by 2, right? From here to here,
yeah.
this is a by 2. So this x part would be a by 2, right? Now, if
Okay.
we talk about y, so this is y, this is a, right? So then what would be this point? This would be hypotenuse square minus this base square. So that would be 3a square by 4. So this would be root 3a by 2, right? So this would be root 3a by 2. Is it clear?
Yes, sir.
So this would be the coordinate of this, but we don't. So let's say that this is minus 2. Okay.
Hmm.
This is, let me use a different color and it would be easy to understand. So this is minus 2q. This is q and this is q, right? So
Yes.
is this a dipole?
I guess if we add those two sides and make it like 2Q, then like a point
Good,
where.
good. But we cannot add charges. We have to get the charges, or we have to do something, whatever we have. We have
Yeah.
minus 2q. So I can
Yeah.
write this as minus q and minus q, right? No harm in that.
Okay.
There are two minus q's at the origin, right? Right?
Yes, sir.
So one dipole would be this, right? And let's say that this is P1. Clear? Minus
Yes,
Q
sir.
and Q. Other dipole would be this, P2. Clear?
Yes, sir.
And what is the angle between these two?
60 degree.
60 degree, absolutely correct. So then we have two vectors and the angle between them. So we can calculate the result. Let's say resultant is P. So that would be P1 square plus P2 square plus 2P1 P2 cos theta. Right.
Hmm.
Now if we theta we know, right? And let's say this is P net, right? So let's write P. And now if we look at these two dipoles, so they have equal magnitudes, right? Minus q and plus q minus q and plus q minus q and plus q, right?
Yes.
So charge is same. Distance between these two dipole between these two point is a, and in here this is a. So distance is also same, right?
Yes.
So P1 magnitude would be equal to P2. Is it correct? Do you agree with this one?
Yes.
And this would be how much? So this would be simply Q into A or AQ, right?
Yes.
Because charge is Q, separation is A. So AQ. Now, let's put all these things in here. So P net would be P square plus P square plus 2P and cos of 60. So we can write it as 2P square plus this is 2P square and cos 60 is half. So this part cancels and this is 3P square, right? So this would be root 3P. So root 3 and EQ. This would be P. Clear?
Yes, sir.
So 3Q, right? Second has B option. So we are B. Is it clear to you?
Yes, sir.
Then please note down this question and then, first note down the question and then the answer, right? Who is joining us? Taha and Vishita are joining.
Sir, I will write down the question and I'll try to do it by myself.
Good, good, good. Yeah, that is a great idea. So